video will complete the series of CST release questions 81 through 90. In my prior video on this series, I did only 81 through 87 because the video was getting to be a little bit too long. Again, you can go back to that or go forward in mine, see any individual or a combination or skip, whatever you want. You've got the control. If you want the information, you can find it here. So let's start out with this question now. Number 8 is iron oxide or iron 3 oxide. It would be here. Iron 3 oxide plus carbon monoxide is going to give you iron and carbon dioxide. That's what you're seeing up here in this question. So what are they asking you about it? This reaction, how many grams? Okay, find is the grams, Fe2O3. And the given is grams, and here's your find. Grams of Fe2O3. Your given is right here in grams of carbon dioxide. So let's do a map of the thinking we've got to go through to make this work. And that involves starting out with grams of carbon monoxide. We need to change to moles of carbon monoxide. Okay, the same stuff. We're going to use the mole ratio to get us to moles of iron. The mole ratio is contained in the balanced equation. And that ratio will be the moles of the coefficient of iron up here and the coefficient of iron oxide. So iron 3 oxide or rust, you can call it rust, that's what it is. And once we get the moles of iron oxide or iron 3 oxide, which is also known as rust, we're going to change that to grams using the molar mass. So let's go down and see the calculations that we have to do just to get started. We've got to know some molar masses, and the first one we got to know is going to be the carbon dioxide, which we are going to be looking at here. Okay, this is how we get our molar mass of carbon monoxide, and the 12 here comes from 12 grams per mole is off the periodic chart for carbon, and 16 grams per mole is the periodic chart number for oxygen. Add those up, you get 28. Okay? Over here, we are also going to need to do the number for rust, and so we've got iron at 112, at half of 112. So we're just multiplying the molar mass of iron by 2 because we have 2 irons in the molecule. And then we're going to multiply the molar mass of oxygen by 3 because we have 3 of those in the molecule. So 48 for oxygen and 112 for iron, and our total 160. 160 grams. We can rewrite this, 160 grams Fe2O3 is going to be equal to 1 mole. And we're good to go on that. Now we're ready to start our calculation. So let's label this as we go along. This is the given. Right here. That's what we were given in the problem. 84 grams of carbon monoxide. See it up there? 84 grams. Right there. Okay. And the next thing we're given, the next thing we're trying to do is get grams of carbon monoxide to moles of carbon monoxide, and that comes from the periodic chart. So I'm just going to label this the chart. When you look on the periodic chart, add up your carbon monoxide, that's 28 grams, which we did up above, and that will give you the mass of 1 mole. That's why we call it the molar mass. Now, these numbers are from the balanced equations, or balanced equation, balanced equation is going to give you the ratio of iron 3 oxide to carbon monoxide. And the last thing we need to do is change the moles of iron 3 oxide, into grams, and that comes off the periodic chart, which we got right up here. Okay, so this is the chart again, which is going to get us from the grams, or the moles, I'm sorry, the moles here to grams here. And let's go ahead and do a quick cross out. Grams cross out, grams of carbon monoxide. Moles of carbon monoxide cross out. Moles of iron 3 oxide are going to cancel out. And we're going to be left with grams. And the number that will go with that, after you run all of this calculation stuff, it comes out to a pretty nice even number of 160, and that's why C is the correct answer. Okay, number 9 here, we're given a balanced equation, and that balanced equation shows us that we're going to be dealing, or allows us to deal with what the question is. We're given 54 grams of water, as you see right here, 54 grams of water, and they're mixed with magnesium nitride, this guy up here, and they're going, well, how much ammonia is going to be produced? Well, your ammonia is right here. So we're going to, how much in grams ammonia are we going to get? So let's look at a diagram of what we're going to do. First of all, we got to get the molar masses. Can't do anything without that. And so for water, as you see here, 2 hydrogens is equal to 2 grams on the periodic chart, and 1 oxygen is 16 grams. Add them up and we get the 18 here. Okay, nitrogen off the periodic chart is 14, and hydrogen is 1 times 3, so that's going to come out to 3, and we add them up and we get 17 grams. Now we're ready to go ahead and look at a complete diagram of what we're asked to do in this problem. Okay, we are given, this is our given right here. We're given the water, the grams of water. We are asked to change it to moles, and we're going to do that by using the molar mass. So molar mass is going to do this little calculation for us, and we're going to change moles of water to moles of ammonia. That's the mole ratio and again, that mole ratio is the ratio based on the coefficient of water, which you see right here, and the coefficient for ammonia, and that will allow us to get the conversion of water to ammonia. Then, of course, the last thing we need is this guy, and we're going to get that through the molar mass. And this time, we're going to use the molar mass of ammonia. And that's molar mass. Okay, now let's go down and see how that actually works out. So here's our given, right here, 54.0 grams of water, which you see up there at the top. The number here is, of course, the molar mass. And the mole ratio that I had up here is what we're using right down there. And the molar mass of ammonia is right here. When you multiply across the top and multiply across the bottom and divide the bottom into the top, you get 17 grams of ammonia, which is why the answer here is letter D. Okay, in this last problem, we're given 5.4 grams of aluminum, which I have underlined in blue right up here. And we're supposed to find, using that balanced equation as part of our finding process, the mass of solid copper, this stuff right down here. So, first off, let's go ahead and find out what our molar masses are for copper and aluminum. We go to the periodic chart for that. And since we're just doing elements here, we don't have to add anything up. It's just the number off the periodic chart, which tells us how many grams there are in every mole of those elements. So we just come on down now, and what are we being asked to do? Well, we are going to be given the grams of aluminum, and we're going to change that to moles of aluminum using this molar mass right here. And we're going to change the moles of copper to the grams of copper using the balanced equation mole ratios. And so we got copper to aluminum, or aluminum to copper in this case. All right, that's where we're going to use those mole ratios we just circled. The next part is to get us back to grams of copper, and the grams of copper is given right up here. We found this, remember, on the periodic chart. So when we actually run the numbers, here's the way it's going to look. Right here, we have the given. 5.4 grams of aluminum, and you'll see that right up here. Next, we have the molar mass off the periodic chart. And that happens right here. Next is the mole ratio. And the mole ratio, I circled the guys that we're using for the mole ratio. 2 aluminums equals 3 copper. That's their ratio. Okay, so 2 aluminums is equal to 3 coppers. This is the mole ratio just plain ratio from equation. And that's where this fraction comes from. And the last fraction comes from this guy up here, again, the molar mass. Now, why do we have this guy on top? Because that's what we were given. And this guy has to be on the bottom to cancel it out. This guy has to be on the top, or is on the top, because that's the ratio of grams of aluminum to 1 mole. And that cancels with moles of aluminum down here, and that number 2 in the moles of aluminum comes from the balanced equation, of course. We cancel moles of copper. This moles of copper up here comes from the balanced equation. The one down here is from the molar mass. And the only unit of measure that we have left at the end is grams of copper. So when you go across the top and multiply everything, and you go across the bottom and multiply everything, and then you divide the bottom into the top, you wind up with 19 grams of copper, which is the answer. That's it, folks. You've seen it all. Hope it gives you a lot of help.